So what if I told you that the world around you, yeah, the chair you're sitting on, the screen you're looking at right now, what if it only exists because you are looking at it? It's a seriously mind-bending idea, right? But it's an idea that actually has its roots in one of the most successful scientific theories ever. Today, we are going to unpack this wild link between our consciousness and the fabric of reality itself. I know, it sounds like something straight out of a sci-fi movie, but this exact question, it was seriously debated by the brilliant minds who basically invented quantum mechanics. So you have to wonder, how on earth did we even get here? How did the most successful, most tested scientific theory in all of human history lead to a conclusion that sounds, well, kind of supernatural? To figure that out, we have to go right back to the beginning of the whole mystery. Okay, so the very first clue is what I like to call light's identity crisis. For centuries, scientists just could not agree on what light is. Was it a stream of little tiny particles, or was it a continuous wave? For the longest time, physicists were totally split. You had Team Particle over here thinking light was made of these tiny little bullets, and then you had Team Wave, who were convinced it was more like ripples in a pond. And honestly, for a long time, the experiments just made everyone even more confused. Just look at this timeline. It's like a scoreboard for physics. For more than 100 years, the wave theory was totally dominating. It felt like the case was closed. But then, boom, the early 1900s hit, and new discoveries, including some Nobel Prize-winning work from Einstein himself, brought the particle theory roaring back. The score was tied, 2-2, and physicists had to face a really bizarre new reality. The conclusion was just inescapable. Somehow, light is both things. It's a particle and it's a wave at the same time. And this weird duality, it was just the beginning. The mystery was about to get a whole lot deeper. So if light has this strange double identity, it kind of begs the next question, right? What about everything else? Could the very building blocks of our universe, of you and me, also be two things at once? And the answer was a huge, shocking yes. In 1924, this guy Louis de Broglie just throws out this wild idea. What if everything has this dual nature? A few years later, experiments proved him right. The stuff that makes up you, me, this planet, it's not just solid little points, it's also waves. And, well, that discovery just opened up an even bigger can of worms. So if the very foundation of reality is this fuzzy wave of possibilities, this quantum haze, then why is the world we experience so solid and definite? How does all that uncertainty at the teeny tiny level turn into the solid, predictable certainty of our everyday lives? Well, the first big attempt to answer that question was something called the Copenhagen Interpretation. And folks, this is where that idea of a conscious observer really steps into the spotlight. This is where the myth truly began. Okay, think about the famous Double Slit Experiment. When you're not looking, a particle acts like a wave and seems to go through both slits at once, creating this cool wave pattern. But the moment you put a detector there to watch which slit it goes through, bam, the pattern vanishes. It starts acting like a normal little particle. It seemed like the very act of watching was changing reality. And this idea that our observation collapses all the possibilities into one single reality is what led so many people to a really mystical conclusion. It's a conclusion that, by the way, Albert Einstein absolutely could not stand. I mean, his comeback was just classic Einstein. He felt like this couldn't be the whole picture. It just felt fundamentally wrong to him that the universe somehow needed us to be looking at it for it to be real. And it turns out his gut was right. The real answer would just take a few more decades and much better technology to find. So fast forward to the 70s and 80s, and new experiments finally gave us the real answer. And the culprit wasn't some mysterious, conscious observer. Nope. It was a physical process that's happening literally all around us all the time. You know, a huge part of the problem was simply the language. This phrase, wave function collapse, it just sounds so dramatic and mysterious, doesn't it? But there's a much more accurate term that clears up the whole thing. And that term is quantum decoherence. And the absolute key to understanding this is that one little phrase, physical interaction. See, it's not about a mind observing something. It's about a physical thing interacting with its environment. A detector isn't just passively looking. To detect a particle, you have to interact with it somehow, right? Like you have to bounce a photon off of it, and that physical bump is the whole game changer. It disrupts the particle's wave, knocking it out of sync. And that loss of sync, that's decoherence. Think of it like a big group of synchronized dancers. When all the quantum waves are in sync, all dancing to the same beat, you get that bizarre wave behavior. That's coherence. But the second they start getting bumped around and falling out of step, the cool wave pattern just disappears. That's decoherence. And this simple idea explains perfectly why our everyday world looks the way it does. So this obviously brings us to the next big question. If everything at its core is made of these waves, why don't we see big things like a tennis ball acting all weird and quantum-y? Well, the answer really comes down to two things: just sheer mind-boggling scale and constant, unavoidable interaction with the world. I mean, just look at this number. That's roughly how many atoms are in a single tennis ball. It's a number so big our brains can't even really process it. Now, think about it. Could you get 10 quadrillion dancers to all stay perfectly in sync? Especially when they're all being constantly bumped by air molecules and particles of light and everything else? No way. It's just impossible. The waves of those trillions upon trillions of atoms are constantly being knocked out of sync, canceling each other out, and we're just left with the average, a solid, stable object. This whole process of decoherence is completely physical. It's logical. The environment itself is constantly measuring every big object, forcing it to pick a definite state, so incredibly fast that we never ever get to see its underlying wave nature. So let's just put it side by side. The old mysterious idea was that a conscious observer collapses the wave. But the modern understanding, the one backed up by experiments, is that it's physical interaction with the environment that causes decoherence. So reality isn't some mental construct. It's what emerges from countless physical interactions. So in the end, your mind doesn't create reality, but it gets to perceive a universe that is constantly creating itself through an infinite dance of physical interactions. The world isn't any less magical just because it's governed by physics. If you ask me, that might make it even more incredible. What other amazing secrets is the universe just waiting for us